Hello, everybody, and welcome to today's webinar presentation titled When Basic Load Balancing Tools from AWS, Azure, and GCP Aren't Enough, brought to you by IONICA. I would like to introduce you to our presenter today, Michela Toscano. Michela is an entrepreneur and technologist based in Vancouver, British Columbia, where she's the principal of IONICA, a cloud computing and cybersecurity firm with clients across Canada and around the world. Michela holds a master's degree in business administration with specializations in technology and marketing from the University of British Columbia. She also holds a bachelor's degree in sociology and psychology from University of Nevada, Las Vegas. Outside of work, Michela enjoys running, cycling, music, spending time with her dogs and her partner, art, learning the French language, programming, and political and social activism. At this time, I'd like to pass it over to Michela for her presentation.
Okay, thank you for that introduction. And thank you for joining me on this webinar about high availability. The subheading is When Basic Load Balance Tools from AWS, Azure, and GCP Just Won't Do. So let's get started. Just a quick agenda. First, I'll just tell you very briefly about a little bit about myself, who this webinar is for, what a load balancer is, super quick introduction to that, what your load balancing options are, why you might build your own, and then we'll do a demo, actually go through and build a load balancer right here in the webinar pretty quickly for a pretty common use case, but this will be a usable configuration that you can look at yourself and see how things work, and I'll explain it as well. So quickly about me, my name is Michela Toscano. I'm the Principal Site Reliability Engineer at IONICA. I've been working in SRE and DevOps since 2007. I specialize in performance optimization, high availability, cybersecurity for internet-connected applications. I've worked for a whole bunch of different cool companies and a lot of projects here at IONICA and elsewhere where we've worked on really interesting use cases, high traffic, high profile sites, high security, and ones that require of course high uptime, which is one of the main reasons why people use load balancers. That and scale, of course. I guess takes to my particular interests, which are high availability, high security at scale. Who is this a webinar for? Well, in a nutshell, it's for anyone who wants to learn more about their options for keeping websites and applications up all the time and fast under all conditions. The topic, the presentation, might get a little bit technical, but I'm going to take you through it all every step of the way and explain what we're doing, almost every little detail, and then the rest I think it'll be pretty easy for you to fill in the blanks. And of course, you can always send an email and ask me any questions if you have them. Love to hear from you. And so what is a load balancer? Yeah, load balancer is a device that of some kind that balances load among two or more machines or devices behind it. Generally, they detect failure and route around it. So if one machine behind the load balancer goes down, the load balancer will usually detect that. You may have to configure, and usually you can set all kinds of parameters around that, but they will detect a failure and then stop sending traffic to the failed device until it comes back online. Big benefit to them is that they enable horizontal scaling, fault tolerance, and maximum performance and uptime. This is a really simplified diagram of what a load balanced environment looks like. There you can see the load balancer, the user is hitting that load balancer through the cloud and then winding up on one of two web servers. And so first let's talk about those platform as a service load balancers, what they are and what they're for. So they're basically like what we described a moment ago, but in kind of a point and click, subscription service form. So you don't have to maintain any servers. You don't have to. You can get up and running really quickly, and have a load balancing setup working for you. We would consider we would call that kind of a one size fits most. Most people probably don't even need a load balancer at all, actually. So just above that in terms of needs would be folks who can get by with basic subscription load balancer from one of the cloud platforms. And they have some downsides too. We'll talk about that in a minute. And then there's enterprise load balancers, which are, just to name a few, HA Proxy, Apache HTTP Server, Nginx, Envoy, and Pound. They're really, excellent. All of those are actually open source load balancers. There's other ones too that you can buy like in hardware form from Cisco and F5, and those have some nice benefits as well, like GUI login panels if you're a fan of that, and support. But you can also get support for the open source solutions as well. From IONICA is one of those places, but it doesn't have to be. It could be from a lot of different companies provide support, and some of these open source projects have corporations behind them that provide support as well. So they're widely supported. Not just that, there's a lot of community support. And just a quick word about those. HE Proxy is probably the most common open source load balancer, maybe one of the most common, definitely one of the most common load balancers in existence. It's highly flexible, highly efficient, very powerful ACL language, basically a rule set. So you can define all sorts of rules based on all sorts of different parameters and conditions. Apache HTTP server, actually, it's known for being one of the world's most popular web server, but it's also a very capable load balancer with a ton of features. Nginx, similar story. Nginx, really excellent lightweight web server that also doubles as a load balancer. Of those two, I tend to prefer Apache because Apache has like what I consider to be a much larger feature set, and the performance is very comparable, or if not basically the same. Some people might argue with that, but there's a lot of different reasons for, the reason why Nginx was so fast when it first came out is because it was one of the first popular web servers to use a threaded model. And at that time, Apache used the pre-fork NPM, which was a process-based model. Every request or session was tied to a process, which is not efficient. When things are tied to threads, that's much more efficient. And then Envoy takes that a step further, where multiple requests can be handled by a single thread. So really, really, that's a really, really efficient and exciting new load balancer, Envoy, relatively new in the last few years. So Apache HTTP server, since they released version 2.4, they have introduced the event NPM. So before they had a threaded one as well, but event kind of takes the benefits of a threaded model to the pre-fork model, and so it's basically it's a threaded NPM, but it also has some of the stability that people required, that the benefit that the pre-fork model had. So you kind of get the best of both worlds. Basically, have really high performance web server with all the features that you need. And another factor in Apache's performance is that now, more than in the past, the separation of concerns between web serving and application serving is more commonly broken out from Apache. So we're not using mod PHP or mod Python, mod Perl as much anymore as people used to do. Now, for example, PHP is handled by PHP FPM. Python's usually handled by Green Unicorn or one of the other Python application servers. And so those duties are no longer handled all on the same web server, and that means that it itself can go faster when those two concerns are separated and those things aren't running kind of in the same process, or together right in the same space. So that's another reason why the gap is really closed. Performance gap between Apache and Nginx is really closed over the last several years. That's not really a new phenomenon, but relatively new, and so new that I guess it's new enough that I think a lot of folks aren't necessarily aware of it. As I mentioned, Envoy is really exciting, interesting, new-ish technology. It was developed 2015, 2016 by Airbnb. Since then, it's been open sourced. A lot of other really big organizations have adopted it. Very exciting. I'm still learning a lot about it myself. I would say still for most use cases, it's probably not the first thing I would pick for an environment that's getting, say, less than 100,000 concurrent requests, because based on what I've seen so far, it's not exactly batteries included, so to speak, as the other solutions are. It has APIs, so you can build any feature into it, but they're not necessarily all ready, like as readily available to you as they are with, say, Apache or HA proxy, where you can just, edit a config file, start it up, and you're done. You may need to build the functionality you want in Envoy. And if you like to talk about Envoy, I'm doing some research on it now, and I would love to talk about it with you if you have any questions about it, or if you'd like to see a future talk on it. I think that would be really exciting. Again, that would probably be geared to like much more high traffic environments and use cases. Pound is an older solution, but it's solid. It has a lot of interesting features, and it's a totally viable option. And what are the benefits of these enterprise load balancers? They're highly flexible and configurable. You can do pretty much anything. Those like HA proxy and Envoy operate not just for around on HTTP layer 7, but also layer 3, layer 4. So you can balance all sorts of traffic. So you can balance Redis traffic or SQL traffic, or pretty much any application with Envoy and HA proxy 2. The difference there is, well, not necessarily a difference, but you might not necessarily, just because you can doesn't necessarily mean you should do that. I think in cases like Redis, you balancing with HA proxy or Envoy makes a lot of sense. But if you're balancing, say, MySQL, MariaDB, Percona traffic, probably should use SQL load balancer. We've done that in the past for one of our clients and had really outstanding results. So the reason for doing that is because you just have a lot more features available to you that are specific to that use case. Caching, telemetry that's for that use case, it's all set up for you, works really well. Query splitting, lots of cool stuff that you can do if you have a database load balancer to balance your database workloads. But HA proxy does work for that as well. So if you have like a 3-node, MariaDB Galera cluster that you want to balance traffic, you can do that with HA proxy. We've done that in the past, and it's actually worked really well. But you can't really do the things like, query splitting, and a lot of other interesting features that consider kind of really important. If you have that kind of scale, you may as well take the extra, one relatively small and extra step and get well acquainted with a good SQL load balancer. And there's a couple of those. Proxy SQL is a really popular one, and the name escapes me right now, but the MariaDB people also have a SQL load balancer specifically for MariaDB Galera clusters. And it's very, very interesting. It has a ton of really interesting features. What are some other benefits to these kind of load balancers? The ability to accommodate large traffic volumes in any use case, not just HTTP, just like we mentioned, and not just database or HTTP as well. Like you could balance email traffic, FTP traffic, all kinds of stuff for most of those, not necessarily all of them. So probably not Apache or Nginx or Pound, but HA proxy and Envoy load balance anything. And one of the coolest things I like about this is that with that flexibility comes with the ability to bolt on any other features or functionality you need. So your load balancer, as it is just a standard Unix machine with some special software on it, you can add a web application firewall, network firewall, static asset cache, a dynamic cache, all kinds of interesting things that help you manage traffic at the edge. And that's ideal because if we're intercepting with a web application firewall, a network firewall, intercepting malicious traffic at the edge at the same place before it goes any further, that's great. We don't want that stuff to ever touch the application servers. So it's really nice when we can do that there, when we can do that before it gets there. Similarly for caching, it's always best if we can to cache at the edge, because then those requests don't have to trouble our application servers and put extra load on them. Similarly, what if we were to, okay, you might say, well, what if we just put it on another machine in between the two? Well, that's a very viable option, and it may be the option that you decide to go to in your particular use case. But in many use cases, that's not necessarily required. So those features don't necessarily need to need to be broken out unless you're getting a really, really large amount of traffic, and so much that those that those workloads can't be broken out onto a different device. But generally, those workloads are fairly light even when taken all together. So load balancing plus web application firewall plus static asset cache, that's a setup that we commonly put all together on one box, or actually at least two together, but a pair of them or more that do the same thing, but they're all have the same configuration. And the reason that's for high availability reasons, of course. So if one load balancer or edge device goes down, there's others to take over for it. The final big benefit to doing your load balancing this way is maximum visibility. The observability tools and functionality available and using this kind of load balancing are really outstanding. And just like all the features here, kind of the sky's the limit. It's really up to you as to how far you want to go with it. And there's a ton of different tools that you can use to gain visibility, but you don't even have to do that if you don't want to. So if you want to, you can have incredible, um, you know, connectivity to, say, feeding all your logs to Elk or to Grafana or some kind of hosted solution, but you don't have to. Um, what you could do is just see the logs in real time on the machine as they come in, and that's really, really handy when you're troubleshooting a problem or trying to find an abusive client, or a bunch of them that are, say launching a DDoS attack or launching some other kind of attack. It's really helpful to be able to get into the edge devices, observe the logs in real time, take action, and then observe the result of your actions. That is really, really helpful. And sometimes it can be a real pain to do that on a platform as a service load balancing device, if it's even possible at all. So yeah, so then I guess kind of continuing with that, why build your own? Well, we've already seen a few reasons when we talked about the benefits to using the other load balance or using enterprise load balancer. Flexibility, performance, definitely, latency, ability to handle much more requests and sessions at a time, security, add TLS and SSL termination, network firewalls, web application firewalls, block everything at the edge, or anything at the edge, not everything. Scalability, lower cost. When you set up a load balancer like this, say you're using one of the popular cloud platforms, you're basically just going to spin up a VM. It can be a fairly light VM in most cases, put the software on it, and you're ready to go. Whereas if you subscribe to one of the one of the load balance services from one of these companies, those tend to cost more than just a VM. We talked about the visibility. There's a lot of features, so many features. Documentation for most of these projects is incredible. Really good documentation, but I think also shows you how much they can do. And the last reason, setting up your own load balancer is actually a lot easier than you might think. We're about to start the live demo now. If you'd like to skip it, no worries. To learn more about this topic and about some of the amazing projects we've undertaken, visit ionica.ca/lb. As well, feel free to send us a message at hello@ionica.ca to ask any questions or to suggest a future talk. I'm going to go ahead and take you through it, and we'll build a load balancer right now. So if you're ready, let's go. So I've gone ahead and set up one load balancer and 2 web servers for you to save time. In production, probably would want to have 2 load balancers with a shared virtual IP. This is actually really easy to do with Keep Alive D. And again, if you have any questions about that, just let me know. If you would like to see another webinar on that, yeah, please let me know that as well, and I can do that. It would actually be a pretty quick webinar on how to set that up. But for simplicity's sake, just saving time's sake, we're going to just use one here. So I'm going to take you through step by step. I've already written out the configuration, and we'll paste it in blocks, and then I will explain each block of configuration parameters. And here's my old config file, and I'm going to just go to the top, and I'm just going to delete all of this. And I explain all of this in just a bit. But this is the same thing that we had before. Okay. Here we go. So the global settings, of course, they apply to all the front ends and all the load balance pools. And I'll explain what a front end is and a load balance pool is in a moment. Basically here we were saying this is where we're defining logs to log to HA Proxy's own dedicated log file. That on enterprise Linux, that isn't set up out of the box. You just have to go through and set that up separately. It's not hard to do, but it does require these 2 additional lines that you put in, plus a couple more. Check the documentation for the rest of the information on that, actually. We won't have time to go through that, but this part you see, so you've got a hint to start. These are just required to run HA Proxy, maximum connections. We're starting here with this load balancer. We'll accept a maximum of 30,000 connections. Beyond that, it'll start queuing them. But this is an arbitrary string. You can set it as high as you want. Base that on, your capacity constraints. So I suggest always load testing your applications and workloads with, specific to your load test your application under the expect load that you expect, or you want to make sure that your stack can handle. Don't go by any kind of like general rules of thumb not for very long anyway, if you can avoid that. User and group is a user and group that the HA proxy process is owned by and run through. It's going to run as a daemon. This is to set SSL up to handle SSL. HProxy didn't always handle SSL, but I believe since version 1.5, it now handles SSL, or TLS is its proper name. This is basically how we enable the statistics function of HA proxy. And here are some of the common defaults. So these are saying these are other default parameters is slightly different than the global context, saying if these parameters aren't defined elsewhere, these are going to be the defaults. So the mode HTTP, it has at least 2 modes, HTTP mode and TCP mode. So we were using HTTP mode because we're balancing HTTP traffic specifically, but if you were balancing, say, secure FTP or email, you would use probably TCP load balancing to balance that kind of traffic. Logging, log applies to the global context. Retries is, if there's a failure, try 3 times. Timeout HTTP requests, that's a request coming into the load balancer itself from outside, from the internet. That timeout for that is 30 seconds, which is pretty standard. 30 to 60 seconds, pretty standard. Timeout for the queue, that's requests that are queued up if they're somehow like the load balancer is really busy, or the connection count, especially if the connection count is over 30,000, then the queue is alive, keeps items in it for up to 1 minute. Connect timeout, that's 5 seconds. So any client has up to 5 seconds to complete like a connection handshake, which should be plenty. More than that, we don't really want to set too much more than that in most cases, because that can become a denial of service attack risk. Client and server timeouts, these are a little aggressive. Generally, this is set to 30 to 60 seconds. We've set it 10 seconds here just for our own purposes. You always want to keep this as tight as possible, again, for the same reason, to control denial of service attack risk. But yeah, 30 to 60 seconds is pretty standard. If you can keep it at 10 in production, good for you. Yeah, that's great. But you probably won't. At least not the server. At least not the client side one. And the client side one, again, is for connections into the load balancer from the outside. Probably best to keep that a little higher. Actually, here, let's go ahead and make it 20. Timeout for HTTP keep alive, 5 seconds. 5 seconds is pretty good keep alive time. Basically, that's the amount of time that a HTTP connection is going to be held open for like pooled requests to come in from the client browser, or even from the load balancer itself, in the case where the load balancer itself is a client to the real servers. So keep 5 seconds, pretty good amount for that. Too much, again, that's where you risk holding connections open too long, and you could have either run up against capacity constraints or exacerbate DOS attacks. Check timeout, 10 seconds. So if a health check from the load balancer to the real servers takes more than 10 seconds, it's considered a failure. Max connections, 30,000. Here we go. We just put that in 2 places just to be sure. And then this is the stats authentication parameters. The username is the stats, and then this is the password here. Okay, so let's go on. Okay, so here's our main front end. Basically, this is a port 80 front end, which basically means it's part of HA proxy that's listening on port 80 for any request to come in. It's binding on that 0000, which is basically all IPs that are on this machine. Port 80, of course, because that's a standard HTTP port. Default backend is dynamic app. We're going to talk about that in a second. Options for HTTP logging, as you can see. So it's a logging type, basically. And option forward 4, that's another logging parameter. HTTP keep alive. So we're saying, yes, enable the keep alive function for this backend. And that, in most cases, you don't necessarily need to enable the HTTP keep alive on the HTTP or clear text backend, because you should mostly just be redirecting people from there to HTTPS. So that's one that you might be able to actually set differently. And if you were to set it differently, you could even just leave that off, which I believe that would then fall back to the compiled in default for keep alive. Or you could set in the HTTP server close option, which basically says after each request, close the connection. And I could just keep more connection slots open for more legitimate requests to come in. And in this case, we're just sending people a redirect. It really isn't. It's not like they're going to be requesting like a bunch of assets or a bunch of stuff that's going to benefit from connection pooling or request pooling over one connection. Better way to say it. Speaking of DOS, denial of service, which we've talked about, I've mentioned a couple times here. Let's use HA proxies denial of service mitigation measures. And here are some. And it can do a lot of different things with regard to denial of service protection. This is just the one that we've enabled in this particular case. This basically says store up to 100,000 IP addresses in the tables for tracking clients and that come in. Allow known IPs to bypass the filter. So that's basically, your office or your home office or your other servers. You put them in this allow list so that these rules here don't apply to them. And so that's useful, especially if you're doing say you're doing load testing. We put the load test kit IP addresses in there just so that they don't get throttled by the mitigation measures, DOS mitigation measures. And basically we're saying, hey, reject any client that requests more than 20 makes more than 20 concurrent connections, which is plenty. So yeah, anybody who's doing more than that, probably not a legitimate request. Now let's put in headers. And these are all things that we're doing here. They're free. We didn't have to pay extra. We didn't have to pay a cloud company extra to put these features in. They're just there. So a lot of times the cloud companies will charge you extra for any DOS mitigation functions that you want. Well, here you don't need that because you put it here. You could also put it in your firewall. So TCP or IP tables, there's a bunch of stuff you can do similar to this, and we do that as well to mitigate denial of service attacks. So again, another way to save money, keep everything simple, keep it all in the same place, use your automation tools to target one way of doing stuff, much more simple, fast, efficient. Along the same lines, here's where we can set headers. We have a lot of flexibility. You can set any headers we like. And in this case, we're setting, this is for HSTS. Basically, we're enforcing SSL, or yeah, enforcing SSL TLS connections. So people make a request on this port 80 front end that we're telling them, we want you to go over HTTPS TLS. And then the rest of these, they're basically for, I won't get into them to save time, but basically they're help protect against cross-site scripting, cross-site request forgery attack. So if you're interested in that, I suggest looking those up and just looking up security headers in general. It's a really interesting read if you're into this kind of stuff. ACLs. So now we're putting in our rules. So we're say this is where traffic goes to under some specific conditions. So here we're saying if URI begins with /xml_rpc.php, then this XML_RPC rule applies. Similarly, if any of these IPs make a request, then this bad_IP rule applies. And then we say HTTP request deny if rule name, and then those requests are going to be denied. And in this case, that means that the client is going to receive an HTTP 403 status code back, 403 forbidden. Here we're just redirecting people over to HTTPS, just like that HSTS parameter does, or header does. And this is just a note I put in here to show you if your site domain must begin with the host header must be start with www. This is a way you can redirect to make that happen. All right, let's go to our next front end, which is the HTTPS or TLS front end. Okay, so this front end, it's called demo.ionica.ca/SSL. I don't know if I mentioned this, but basically that's an arbitrary string. You can name it whatever you like. Here we're saying listen on all IPs, port 443, of course, standard port for TLS traffic, HTTPS protocol in particular. And then here it's a little different because we're saying, okay, use SSL. Here's the certificate path. Now we have using that same log method or mechanism, format, whatever you want to call it. And then the default backend is dynamic-app. This is for these options. This is options for logging. And then we say, and then we're saying option HTTP keep live. We're going to enable the keep live option for this front end as well. Here's all our DOS, same DOS mitigation measures. And then same headers except for one. We've added one here, and that's basically saying, basically what we're doing is we're saying to the backend servers, the web servers behind this, that to set a header saying this is SSL traffic. Even though it might come to you on port 80, consider it SSL traffic because it's coming from a proxy that has handled SSL for it on its behalf. Otherwise, the application, if it's expecting SSL connections, it may misbehave. And a lot of frameworks and application servers do expect TLS. So if they don't have that header, they might redirect traffic over to back over to HTTPS, and you'll have like a redirect loop, or the application just might refuse to serve a request that doesn't have that header. So it's, we put it in, we just put it in all of our standard configuration. Okay, and then these are some rules, different rules governing where traffic goes to, and this is we've set this up just to show you what it would be like if you were to have a static asset cache here. And so this is, we're setting up a rule called dynamic, another one here called static, and saying if the HTTP method is post, it's a dynamic request. Of course, because when someone's sending a post request, we don't want that to go to cache. We need that to go to the actual application servers to process that post request. It's probably filling out a form or something like that. So we don't want that to go to cache. If it did, it would just be passed through, hopefully, usually. But just to make things really simple, we don't, and also fast and efficient, we just want that to go to the application server because we know that in every single case, that's where it needs to go. Okay, and also we're here saying, okay, for static assets, we're saying any URI that begins with a string /media or /assets, we apply to or I guess goes under this static asset rule. And we can do the same thing here. We have just another one defined here for these other ones. If the path ends in these strings, common ones that are sent to static asset cache. And that's if we want to like make really sure that those assets get caught, even if maybe they're not in one of these two places, media or assets. Okay, and then here we just say, just like above in the HTTP pool, we say same method here. We're saying use backend static app if static, and now we're saying the same thing. Use dynamic app if it's a dynamic request, if it falls under that dynamic rule. Okay, and finally, the last block of rules, almost done here, is this. Okay, so here are the backend rules. We're saying we're defining two backends, one dynamic dash app and another one static dash app. Just like you could see up here, right? That was kind of a clue, right? Because obviously they had those things have to match. So we're saying, okay, here's the dynamic app backend. It's going to use the least connection balance method. And there's a bunch of different balance methods available here with HA proxy. As with Apache HTTP server or Envoy at least, and I believe Pound also has a whole bunch of different ones. Nginx has at least a few different balance methods. HA proxy has a ton. So we're just using least connection, and as you can imagine, that basically means send the next request to the real server that has the lowest number of active connections. And here we say it's option keep alive. We were still enabling that, and that's for the backend now. So for connections from the load balancer to the real servers, we have a keep alive there as well, which makes a lot of sense, at least in this case. In some cases, it might not make sense. Say if your web servers have really limited capacity, you might want to use that HTTP server close option instead of this. This check. This is to say we can actually do in a page check, and this could be a health check page. It could be just the main page of the site that you're balancing, or something else. Basically saying if that's the thing to check when we do our health checks. So here's where we're defining our servers. Obviously, that's what that server means. Then this is an arbitrary string. This is just what I chose to name these two servers, their IP address, the port that the real server in the back is listening on, port 80, and then here we have the check interval 30 seconds. So because we have this commented out, that basically means that HA proxy is using its default health check method, which is, I believe that is the HTTP head request. So it's basically just checking, okay, is an HTTP server running on port 80 on this host? If yes, and I get a response in a timely manner in that 10-second window, remember from before, or a valid response for the head request in 10 seconds, I'm going to consider this node healthy. But if we were to uncomment this, then it would have to get a valid 200 OK status code from the web server on this page in order for that to happen. And finally, we have the waits here. Well, wait, I have it commented out because we're not really, it's not something we really would need to use here. But just to show you, you can wait traffic, you could say. So in this case, we're sending, a lot more traffic to Web 01 than we would Web 02. And there are reasons you might want to do that. Say the two machines aren't identical. Ideally, the two machines have identical amount of resources, but maybe they don't for some reason, and that can't be avoided. Well, you can weight the number of requests. You can weight that workload that you're sending to them so that one of the machines doesn't get overwhelmed. Similarly, maybe one server has other work that it's doing. So other backend processes or procedures or other stuff is going on. Maybe there's other applications that use it. And so in that case, you wouldn't want to send the same amount of traffic if they have different amounts of load that they're already dealing with. So this is where weight comes in really handy, and we've used it in cases like that before. It works really well. Yeah. So now that that's all done, so much talking. Okay, so now that that's all done, I'm going to save this. I'm going to reload the HA proxy configuration. Now, nice thing about HA proxy is we could do a restart here, but we're doing a reload because when we do a reload, we're not going to drop any connections when we do that. That's a really nice feature. We can reload configuration without dropping anything. Okay, so reload, done. It looks great. So let's go over to our web browser. Hey, and let's see. It works. It works. Now, I noticed before when I was testing this that it mostly goes to server 1, and I believe that's because we have the least connection balance method in place, and that's because basically there's no traffic except for me testing. And so why is it doing that? Well, it's just because they both have 0 connections, so it's going to go to 1. So that's pretty much everything. One more thing I can show you is the stats, which are pretty interesting. So I'm just going to grab this. The stats is the username. Let's come here. Boom. And here's what the stats page looks like. It's pretty neat. And so of course there isn't much going on here because it's just me hitting this, but you know, when your site's really busy, your application's really busy, this can be pretty interesting and also very useful. So this is really a nice feature to have. It's just a built-in stats engine that you don't really have to do anything to configure. It's just there ready for you. You can also see machines that are in a down state that would show up here, or if you take a machine out of the pool, you'll see that it doesn't appear in here, so you'll know what's going on. That can be really helpful, as well as you can marvel at the massive numbers of connections that your websites get, which is sometimes really wild to see. When you see when you have a busy site, you think you do, and you see some really high numbers in there. That's really cool. Some other ways you can enable stats, like I say, if you want, you can put Apache in front of this, Apache proxy to HA proxy, which actually is very low expense in most cases, unless your site is really unless your site's really busy. Really busy actually. Most cases it doesn't matter because we're doing that on some really busy sites. Balancing from Apache to HA proxy, it's working really well. And what that does is, again, like I mentioned before, it gives you the ability to block requests at the perimeter, and also some opportunity for more stats with Apache's own stats engines. So that's where you can see requests and not just sessions as Apache or as HA proxy views them. Really cool stuff there. So I think that's helpful as well. Yeah, I could talk about this all day long, so I'm gonna probably leave it here. And if there's anything else, as I mentioned, you want to hear about anything else, you have any questions, we're here. Thank you so much for tuning in, and yeah, we'll talk to you soon. Thanks for watching the webinar. Back to you, DZone.
Great. And with that, I would like to thank Michaela for a phenomenal presentation. Secondly, DZone would like to thank IONICA for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.